All right, everyone, I think that we're recording now. So, yes, we are. Welcome to the second day of the workshop series on energy modeling. Today is going to be us wrapping up the basics of energy modeling in a spreadsheet and getting ready for the software. So to pick up from last session, we were on our plan set for the example single family home. We just finished going over all the windows, and we all did an excellent job finding the windows, FYI. Pat yourselves on the back, that was excellent. So if I pick up the spreadsheet again, the next section that we're going to work on is going to be the dimensions of the house. So with our example energy model that I have already created, this is just going to be something for us to use for guidance for today. This is every input for the home in the energy model. Are you guys on Zoom? See it closer? Yeah, unfortunately, this is the only screen we have, so if you want to get closer, front row's wide open. So on the left-hand side is all of our inputs, and on the right-hand side is going to open up controls for everything once we select something. So when we're focusing on the dimensions of the house, we basically separate the house into different zones based on the HVAC system that those zones are powered by. So for example, we have the living space of the house is one zone because it has an HVAC system, like heating and cooling. It's the same equipment that's using or that is giving space heating and cooling to the whole house. So it's all under one zone, which is this little like temperature looking thing. Those are zones in the software. So within each zone is basically a room, and you have to give each of those spaces a floor area. So when we're doing the dimensions, we keep the spreadsheet so that we can calculate the entire floor area just of conditioned space, because we're in the zone that is working with conditioned space only. We also model the garage. That's modeled as unconditioned space. The zone type right here is a res garage. So we have to model these things differently. Spreadsheet just keeps it all organized. So basically the calculations we're going to do in the spreadsheet are going to be getting this floor area for the whole house. And then these are all the walls. We have an FLBR in front of every wall to differentiate the front, left, back, and right walls. And we have the orientation of each of those walls so that the software knows where they're located in space. So the only area calculation that we get for these walls is the wall area that's like basically has the outside on the outside of this wall. It's like the exterior wall area is what I'm trying to say. So any wall area that has something behind it that's a building, even if it's on the front wall, we're not going to take the calculation for that because these are just exterior wall areas. So we get them for the front, left, back, and right walls. And we do the same for the garage space. We get the total area of the garage space and any exterior walls. We have a front, back, and right wall that are exterior walls. The left wall is a connected wall to the living space. So we only have to model that once, and we modeled it in the living space. So we're going to go to the building plans and add this information into the dimensions tab. So in an ideal situation, you're going to have all the measurements that you need on the building plans that are pre-calculated by the architect. That's an ideal situation. Most of the time, we don't have the ideal situation going on, and we're going to have to do our own measurements for certain, either like small spaces that we have to get a measurement for that aren't identified, or an entire length of a wall that's just not included for some reason. So in those situations, we use an engineer's ruler, and we use the scaling of the PDF to kind of calibrate the screen. One way to do that really easily is using any of these doors. Doors are usually 3 feet 0 inches wide. Sorry, 2 feet 0 inches wide. It's best to just look at a measurement on the building plans and identify the length that you're trying to measure. So for everyone on Zoom, this is what we're looking at for an engineer's ruler, where they have different scaled measurements on the ruler. And this makes it really easy to measure things on building plans, because building plans will give you a scale on every page. So for example, this page has 1/4 inch equals 1 foot. These engineer's rulers are really helpful because there's actually one side of it that will be a 1/4 inch scale. So every 1/4 inch tick mark on the ruler is going to be a foot measurement on the building plans. So that's a great method for any measurements that you don't find on the building plans, and just make sure that you calibrate it by first looking at any measurement on here, like this width right here, 7 feet 6 inches. You would just scale your PDF size, scale the zoom of it in or out until you match that width. And I just write down the scaling. If it's like 104% or 97%, just write that down so you can stay consistent with all of the measurements that you use. So we're here on the first floor, and the best way to do these measurements is to look at the space as if it's a large rectangle, and you're trying to get basically you're trying to encompass all the conditioned spaces. Oh, that's not going to work. So I'll just draw it with my mouse. So we're trying to encompass the whole building in a big rectangle. So going around all the spaces, and then we're going to make cutouts. So if we were to trace that whole rectangle that I just drew with the mouse, then we're going to want to cut out this space right here as a small rectangle, and that would be a back left cutout, I would call that, because it's on the back left side of the page. So we do cutouts like that one, and then also I would consider another cutout to be the whole garage, because in the building, the energy model, we're going to be modeling the garage as its own zone. So we want to know the measurement of that, and it's easy enough to do it all together. Yeah, or the simpler way to just be would just be to do this whole rectangle and do it separately. That actually looks like a lot easier way to go about it. So let's do that. So the front wall length, starting from this side of the garage all the way across to the end of the house, we have 46 feet 0 inches. So that's going to be our width dimension of the whole first floor of the house. So I've already kind of gotten this sheet organized for different floors. So floor 1, we have feet here. So it's going to be 40, there's 46. So we have 46 feet 0 inches. And then the columns on top of the spreadsheet, there's the FLBR. And those are just your front, left, back, right wall. And in the spreadsheet, we have these automatically calculate out the feet and inches into a fraction of a whole number. That's all that this is doing. So it's saying the front wall is 46.0 feet. And then the dimension of the side wall from the very front to the very back is 26 feet 9 inches. So that's going to be our left one, 26 feet 9 inches. And that automatically calculates out to 26.8 feet. Welcome, Richard. Thanks for joining. So this basically gives us an entire area by multiplying the front wall times the left wall, and we get 1,230.5 square feet. Thank you so much. Very helpful. Just got my engineer's ruler. I'm really excited, so we could go through any calculations that are not included in the model now. So yeah, it's a super simple design, luckily. So that's our whole first floor house dimension. It's just one big rectangle. And this should just be equal to J12. So this is our first floor, pretty much ready to go into the software, or almost ready to go. So we have our window codes for the front, left, back, right wall. And then we have our dimensions. So now we could do the garage. Anybody want to look out the garage dimensions for me? Any brave souls in here? Yeah, so the front wall dimension. Thank you very much. Excellent work. 20 feet 0 inches. And then the left wall dimension of the garage. It looks like there's a space in here that's not included because there's a little break right here. Otherwise, you would be able to add these up. And another thing to mention is they're pulling this dimension from the inside of the wall. Yeah, so we could see if there's any other spaces. So there is this full dimension of the 26 feet 9 inches, but we would need to know what this small cutout dimension is to get that. So this is where a ruler comes in handy. And I'm going to go ahead and calibrate it right now with the ruler that I have. So on the quarter scale side, calibrate it to 10 feet 8 inches. Is it 14? Trying to calibrate it, and I think I went the wrong direction. 97. I'm trying to get. Oh no, I was going the right way. The zoom on this is going to have to be a lot, like 125%. I'm trying to get this 10 feet 8 inches to match up on the quarter thick of the ruler. No, that's not 15 feet. Oh, I'm totally going the wrong way. The wrong scale. There we go. 12 feet. Let's go smaller. There's 11 feet. So we'll go to 9%. Okay. We're at 10 feet 8 inches just about on the ruler. So now I'm calibrated. I'm going to remember that this is 89% zoom for any other measurements that I need on this ruler. And the whole length of this wall from the outside of the garage on the top to the outside of the garage on the bottom, I'm getting 24 feet 0 inches. So we're going to use that for our left wall dimension, 24.0. And there's no cutouts in here. So we're going to leave it as is. And that has a total area of 528 square feet. Now we'll go to the next page. For the second floor plan. And this left side is just a deck over the garage. That's not going to be included in our area calculations because it's outside. And we're just concerned with the indoor conditioned spaces. So we're going to take a rectangle around this whole second floor of the house, tracing around. And actually we're going to go above up to here and go all the way across to make a large rectangle around the whole house, and then we'll cut out this space afterwards. So the large piece of the rectangle, does it have a full dimension on here, or do we have to do that ourselves? It looks like even the left side dimension is pulling from the inside of each of the walls, and we want from the outside of each of the walls. So I'll just use the ruler and do this one on each side. So the left side of the house, same zoom on a quarter scale ruler of 20 feet 8 inches. And the length or the width. You guys could add up that dimension up top and spot check me if you're curious. The outside of the left wall. It doesn't go that far. 48 feet 4 inches. Yeah, I actually think that is the whole length of the entire first floor of the house, so we could use that same dimension also. And that one's 46. That's a little off. Okay, we'll go with the 46 value. Because it's more consistent with the first floor. Okay, so in this cutout dimension, we have the length of 28 feet 3 inches for this little back right cutout. So 28 feet 3 inches is the width, and then the height of it. Use the ruler again, 1/4 inch scale. The outside of the back wall. 5 feet 10 inches. And then the calculation here is taking the whole area of the entire rectangle, which is 950.7 square feet, and subtracting 165 square feet roughly of that back cutout. So the total area of conditioned space on the second floor is 785.9 square feet. So now we have all of our dimensions completed. And we're going to bring these over into the floor plan tab. Oh, good catch. Yes. There's a section here where I'd like to take the building plans. There's a total area of each floor on the front page of the building plans. And I do like to compare that to the value that I got just to see how close we are. So do you have that value from the plans? 760 square feet for the first floor on the building plans. Is 98.4, 103.4. So we're a little under, a little over. Balances out pretty well. Usually when we're doing energy models that go to building officials or go for plan review for an actual project, usually if it's within like 5 to 10% above or below, they don't give us any issues on it. So I'd say we're in an acceptable range. Go ahead and move forward. Thanks for that reminder. So the floor plan tab is where basically all of these area inputs are calculated for the energy model. So I have a separate row for each of the zones. And I'm going to go ahead and copy these rows in. So we'll have one for the first floor, one for the garage, and one for the second floor. So one living, garage, and floor 2. So as we go across the spreadsheet, basically I differentiate each of the floors on this column, the window codes that we calculated from the window, it's on the dimensions tab. I just basically pull like a paste link into each of these for the window codes so that if I ever change them back here, they automatically populate into this floor plan and they automatically update for me. So the window codes go here for the front, left, back, right walls. And then the area of this living space goes here, exterior wall lengths of the front, left, back, right walls. These are basically coming from this top row, our main rectangle for each of the spaces. And then if we have any cutouts we basically do that calculation over here. So, or over here on the connecting wall length. So the exterior wall length then gets converted to the exterior wall area by multiplying it by the ceiling height. And it gives us these values for the front, left, back, right wall. And then they're gonna add all the wall perimeter lengths up to give us the perimeter length of each of the zones. So this is needed in a space in the energy model where they talk about the crawl space. And then we give the area calculation for the slab, which should usually be the same for the raised floor on the second floor. And then usually it would be the same for the roof as well, depending on how detailed the plans are and how much they change. So then we would go into connecting wall lengths. For example, that wall that connects the main house on the first floor to the garage, we're going to have that included here. And then the connecting wall area. And this is going to be so that we can model our interior wall. Sure.
Everything you're assuming
Yeah, so I separate the spaces the way that I am just so that I could have the floor area of each floor. And I consider those separate zones because they have different elevations. When you have different HVAC systems that have separate controls, like a multi-zone system, and you have a control in the bedroom, you have a control in the living room, those would also parcel those spaces out into their own zones. So if you had a multi-zone, let's say you had 2 different zones on the first floor, you would do like floor 1 living and kitchen and floor 1 bedroom and like gym wing or something like that, whatever you would have it for. So that's how you would further break it out. And yeah, that's why this spreadsheet is so helpful, is because it can really help to just like convey how you're going to structure these spaces in the energy model. It does take some thought process of figuring out how you parcel out the spaces before you even break into this spreadsheet and before you start the model. Usually just doing the spreadsheet itself can help develop how you're going to separate these spaces out, because this is basically just the numbers of how they're all, where they're all located in space. And then when you come to actually build the model, we will build our own model. This was just what I was using to give reference of why we're doing what we're doing. But when we do build our own model, yeah, you get to see different layers, and you do have options on what you can do. You could just do everything in one zone for the first floor and the second floor. I choose not to do that. I like to be more detailed in it, but there are options and ways for you to do that. So to fill in all the blanks here, I'm going to go ahead and kind of plug and chug really quick. And this is for the living space, front wall length, coming from height link. That's coming from the floor 1. Okay, so the next link is going to be copy and paste GH and I row 12. So paste the link, G12. I'm just going to copy and paste and change H12, I12. So these are the exterior wall lengths that we just hard coded in, and then these are the calculations that multiply it by the ceiling height. And while I'm doing this, if you guys want to check through the building plans, go to the building sections page. I'll have you guys differentiate the ceiling heights of each of the floors, and then we can add that in together. So the perimeter is automatically summed up based on the exterior wall lengths for the space. The slab, I'll go to the dimensions for floor 1, copy and paste the link of this area. Beautiful. So 8 feet tall ceilings on both spaces. That changes up our calculations a little bit. Really? Interesting. Yeah, I think we're still pretty good. That's weird that they have 2 different calculations though. Okay, so the first floor living space, we do have a connecting wall. We'll go back to the plans, show us where that is. So it's going to be the right wall of the garage is our connecting wall on the first floor living zone. Since we already took that dimension down, we'll just look for the right wall of the garage. So floor 1 garage right wall is 24 feet 0 inches. I'm going to copy that link and put it into the left wall of the first floor living zone. And then that's going to automatically calculate the wall area. So the connected wall area is 192 square feet, and that's the wall that's connecting the living space to the garage. The software doesn't really care where on the side wall you're cutting off the interior space from. All it really focuses on is, I'm sure there's some internal calculation that says, oh, if your area is 1193 square feet, there's no possible way that you have this much wall length on your front wall. There's got to be some internal calculation for that. I just don't know what the threshold is exactly, but they do pop up error messages if you're off by some crazy amount. But really, other than that, if you have an interior wall, all you're really doing is you're differentiating what space it's connected to. So the software kind of like pieces everything together, probably with like XY coordinates based on where you say things are, like what the elevation is and what this wall is connected to. But it really doesn't matter if it's like on the front side of that wall or the back side. But no, it's pretty loose with that. So now I'll do the window codes because I used wrong window codes on that portion. And So the garage space, 22 feet by 24 feet. That one is going to be GHI 016. Automatically calculates the exterior areas, perimeter. Need to get the slab, which is 528 square feet. And the connecting wall lengths, we already have it accounted for in the living space. So we could do the same calculation here on the floor plan tab, but when we do the energy model later on, we don't have to include that. We only need to include it once. And the windows, GHI 19. Although it's tedious doing this floor plan tab and like doing everything a couple times, I think in the end it's completely worthwhile. It's really helpful when you're going back and looking at a project that you did a few months ago or 6 months ago or a year or two ago. It has everything outlined really well, especially when you're dealing with building departments and you start like a draft model for a project that's going into design phase. You help them do the energy model, and then you know, you usually have to wait like a year for the project to actually go into construction phase. So, you know, we don't have to do anything with that project for a whole year. And if I didn't have spreadsheet systems like this that Michael Winkler created, it would be really difficult for me to like be efficient working, because I would have to go back and look at the building plans again if it changed anything. It's totally worthwhile for me. Okay. Especially when you do multifamily projects. Wow, that's pretty wild. This is what the area was mentioned here, and I didn't get it, so I'm going to do it equals the slab. We updated the slab area, not the actual area. So equals. We've got all the windows, exterior wall lengths. The perimeter is automatically calculated. We have no connecting wall lengths. But we do have a roof on the second floor living zone, and the total area is 785.9. So we're going to put that, instead of on the slab, we're going to put that on the roof. Paste the link, then I'll say the area. And delete this out. These are old, relevant. So there's our floor plan tab. And we're almost ready to do the energy model. Now we go through the building plans and we're going to do some investigation work. I'd say if we could break up some of these things, have, let's say like one of you guys doing the wall heater, or sorry, water heater and the HVAC equipment, just looking towards the end of the building plans for a mechanical sheet that would have it in the notes. And I will look for the, let's see, slab and roof. And then if somebody else could look for the U value and SHGC value of the windows on that Windows page. And if it's not included there, I doubt it's going to be included anywhere. So if you don't see anything, just let me know, and we can use basic assumptions based on the 2016 code minimum. Yeah, let's go for it. What page are you finding this on? Cool. Oh, Peter. Yeah. Good call, though. So assuming that you have never done an energy model on this project before, where would you go in the plans to find it? And we could do some guidance on this too. So I would start towards the end of the building plans to look for these details, but not as far back as the energy model. Yeah, sorry for not mentioning that. So these are code minimums on the end pages. So I'd say page 20 is where the building plans actually end. Yeah. So I'm gonna hunt out some information on the studs. What's that? You found the windows? Okay, great. Yes, that's exactly what I was looking for. So the building plans explicitly say they refer to Title 24 for the window U value and SHGC. So the minimum requirement for windows in our climate zone 2. Hold on. So I'm going to go back to that prescriptive package A document in the building plans to find these minimum values. So climate zone 2 is in the second column. The window maximum U factor is 0.32. We could go lower than that if we wanted. I think an acceptable range would be like 0.18 to 0.32. 0.18 would be super efficient windows. Maybe 0.25 would be a little bit more affordable. So we'll just go ahead and push them a little bit. We'll push the client into doing something that's a little better than the basic code requirement. So we'll say U value is 0.25, SHGC value. They give a recommended maximum of 0.25. And that's just how much heat you're gaining through that window. I think this climate in Santa Rosa, usually you're worried about the heat coming through the window, so you want to keep that value the lowest possible, so you're not gaining heat from the outside through your windows. In climates like Humboldt or marine climates or places that get a little chillier, you want to maximize the solar heat gain that you get in the wintertime. So we would, projects up here, we would recommend we could do the same U value, 0.25 of blocking the radiant heat, but then the SHGC value of like 0.5, so that you're allowing more of the UV radiation into the window to give you that heat gain in the wintertime. So we'll go ahead and say that the glass doors are the same. So is there any information on the HVAC or water heaters anywhere else? Thanks for hunting. Okay, let's go ahead and call the client up and ask them. Ring, ring. Oh yeah? Okay, cool. So we're gonna go to the end page on the compliance details after they told us what they want. And what do we got for the water heater? Oh, we're on hold. Okay. I hope I got all that. Okay, so we've got Rheem NEA rated heat pump water heater, 80-gallon tank. We have a model number, and the most important thing that I would ask for again on top of this is the energy factor.
It says NEA rated.
Oh, okay. So the software already has predetermined water heaters, and if it's NEA rated, basically they just go off of their own like super calculation, knowing that it's really efficient. So we could just go ahead and say the energy factor is, we'll do like a 2.8 on this. The HVAC system. Split heat pump. You guys know what a split heat pump means? Anybody have a question on it? Okay, so a split heat pump basically means that you have a compressor unit outside that's collecting the air, and it's separate from the fan coil unit that's inside blowing the air. So the different types of heat pumps, there's a package heat pump, and that is where like the whole system is all in one. It's collecting air from the outside, and it's pushing air out of the system, and it's all in one unit. They have large systems like that, and they also have smaller. I can't think of a large system like that actually, but I guess just like central space heating and cooling in your house. It'd be like in your closet somewhere in the main house. But for packaged terminal heat pumps, those are like units that you'll see in the hotel room, things like that. So those are all just contained in one unit. You get air through the wall, and then it pushes it out through the front of the unit. The compressors inside of that main packaged unit. Yeah, the heat pumps need to get ambient air temperature to collect heat from that air. If you have like a heat pump unit and it's collecting air from inside your house, it's doable, but I think that it just kind of, yeah, it like pulls away from the idea of having an efficient home because you're pulling more energy out of the heat that you're already producing. I don't know, you ideally want ambient heat, ambient temperature from outside. So you can pull like a duct through the wall, or just like louvered wall to the garage or something like that would be a better method. Yeah, Yeah, garages are good locations to have a heat pump. The compressor unit, like a heat pump water heater, it's standard for those to be in a garage or like an outdoor closet somewhere with a louvered door. So yeah, unconditioned spaces or like the exterior of a building are great locations for heat pumps. Okay. I have one at 17 degrees Fahrenheit. And is that cooling or heating? Oh wait, sorry, one second. Cooling. Great. Does it have the BTUs for the cooling? Or is it all combined? Sometimes it separates out the heating BTUs and the cooling BTUs. Oh yeah, right here. So the split heat pump with the HSPF 13, that's under heating. And then the BTUs down here, and then there's another one for cooling. Oh, you're right. So no BTU output for cooling, not specified. Okay. No. The CFM is not accounted for usually with the HVAC. Those are accounted for with the fans. So you'll see the fan systems down here. So there's a single speed furnace fan, and that is like the fan coil inside the house that works off of the refrigerant line from the outdoor compressor and blows out heating or cooling into the house. So they give you like watts per CFM. It's usually a standard value that the software will automatically populate unless you have some sort of like a heat recovery ventilator system or extra fans. That's where you want to really pay attention to the CFM and the watts per CFM. So I'm going to go through and find the information on the studs again. Thank you for the HVAC and domestic hot water info. Usually in these details, you should be able to see the stud information, and we're looking for like 2x4 or 2x6 is typically what they will have on the plans. Those are like standard construction. And then we also want to know the distance between each stud. So there's a 2x at 16 inches on center, 2x10, probably in the roof. 2x studs at 16 inches on center. Let me know if you guys find anything before me. There's a 2x6 stud at 16 inches on center. And that's coming out of the concrete slab, so it's the wall studs. So walls. We're also looking for insulation values of all of these. So if you guys remembered seeing those anywhere on the plans, feel free to get a head start. So the insulation values that they give in building plans is usually going to be an R value. The R value, it differs with the thickness of the material based on what material you're using. So if we're using batt insulation, which is just like typical, like a roll of insulation, fluffy stuff that you put into the cavity of the wall, those have like a standard R value that you would use, and those are easy to differentiate or easy to find in the building plans. If they don't actually specify the R value, you can do like a calculation based on the thickness. It gets more difficult when you have spray foam insulation. At this point, any place you could find it is going to work for me. All right, I know you found those wall values. What do we got for the wall insulation? R19, beautiful. That's going to be a cavity insulation. You could fit R19 inside of a 2x6 wall. That's about the maximum that you could get in a 2x6 wall cavity. That's good. How about raised floor? Do you have anything for the studs and the insulation? It could be. I just found a detail right here that looks helpful. So they have R21 fiberglass insulation between joists. So this is the floor joist. There's the foundation, and then they have rigid insulation around the foundation. That is good to know. Cool note right here. So it's an insulated slab. It has slab edge insulation, is what they're saying. Around the edge of the slab. It's not like entirely underneath the whole thing. So I would say R21 at the raised floor based on this detail. And yeah, on page 10, they have some good details of different spots in the building. So this one is R38 insulation between joists, R21 in the walls. Interesting. open decking, gradient barrier. Yeah, on the building plans, when you actually look at a section, it'll have like a little circle with a 6, and that would tell you to go and see the D6, detail 6. So if we were curious on like where exactly this detail is, for example, on the building section on page 8, they have detail 10, and they circle the area. So that would be a detail where we could find that raised floor installation. So if we go back to the page we were just on and find detail 10, that's going to be R21 insulation for the raised floor. And then go back to the details. Anything else that we're curious about? The roof, I think I saw something that said R38. Yeah, R38 insulation for the roof. And then do you have information on the studs that you can pull from your magical location? So the raised floor and the roof studs. Yeah, which studs are those for 16 inches? Oh, okay, exterior wall. So 2x6 wall studs. I'm looking for the raised floor studs. How about we go to the energy model? So for the raised floor, we have no crawl space. Don't have any studs specified. Okay, we'll go 2x10, 2x12. Try that. At 24 inches on center. Raised floors, do 2x10 at 24 inches on center. Okay, well done, you guys. Are there any other questions on the spreadsheet before we move over? Oh, we're almost done. Okay. Yeah, so we finished our spreadsheet. Woo! Lots of work, very well done. So now we're going to save this one. And I'm on a 89% zoom. Please keep track of that here. So if I ever need to come back and do measurements, I can.
So,
Yeah.
so like, right now you're looking at a screen that's bigger than
Mhm. This is true. Yeah, I mean, ideally, I would be on the same computer, picking up work on the same screen. So it is helpful in that situation. In this situation, you need to take that into account, probably recalibrate it if you ever did this somewhere else. Yeah. Do you guys have any questions about all the details? Because this is essentially everything. Everything that we should be needing to enter into the energy model.
So in this spreadsheet, it says
I do. Yeah, so the floor plan tab does have all the window codes just because it's a little bit easier to organize all in one location. But when I do input everything into the energy model, I will have to go and kind of like double refer back. You know, I have to come back to this page to see the dimensions. And when I do most of the projects in the energy model, I'll start one model of just the windows. So I'll start a model and I'll just add whatever I need to add to get to the place where I start adding windows. And I'll just start with all these symbols. And I'll just input all the information that I need to. And then when I'm working in the software, I'll open up a new one, have the window model on my right-hand side, and when I get to the wall information, I just kind of drag them in because you could easily, you can export HVAC equipment from one model to another, and you can also just kind of drag and drop things from one model to another. That makes it really efficient instead of having to kind of like switch back and forth between the spreadsheet. So when we meet next time, we're going to have an introduction to Energy Pro, the actual software, finding information that we need on the property, location, and basically showing you all how to structure a model. One thing that really helped me out was when you actually download the software, in your, I think it's in your documents. So I'll go to Energy Pro 7 documents, and there's a folder for projects. And Energy Pro gives all of these example projects. So they have, let's see, yeah, like different air conditioning systems, different ways to model them. They have a high-rise residential all-electric project, Greenpoint rated single-family example, zero net energy sample home. So some of these were really helpful for me when I was practicing for the CEA exam. And basically for the CEA exam, you have to understand the building code, and you also have to understand the software really well. So it's like saying basically that you're an expert at it. CEA certification is really helpful when you're working on projects that have to get rebate incentives, or if you do like Greenpoint rated or LEED inspections for a project, they'll give your project extra points if you have a CEA and do the energy models for those projects. So the CEA is kind of like the best case situation that you could have with an energy modeler doing your work. It's just the way that the building department can know that you took rigorous testing to prove that you know how to navigate the software and you know how to read the building code. Basically all it is. But CEA is a certified energy analyst, and it's through KBEC. which is the California Association of Building Energy Consultants. And actually, KBEC has conferences every year, which are they're actually pretty cool. They talk about the building code on like a super basic level. A lot of people who are just trying to become the CEA or just started, they'll walk through changes in the building code. They walk through tutorials on, like if you're just getting started and you have these basic issues with the software, they have people that come in and do examples of like how to work through problems. And it's kind of like just like a cool kind of reunion gathering, like talk to fellow energy analysts, energy modelers. It's a great place to network also, like just meet people and have people to call when you come up to a problem that you don't know the answer to. It's nice to have that kind of network of people who are all kind of dealing with these code issues. Everyone deals with the same kind of problem. So that's a cool place. I would recommend you guys check out the KBEC conferences. Also, Energy Code ACE is having their first conference, I think, early next year or something like that. Energy Code ACE is the free website tools that break down all of this. Like everything that I'm doing, they have training sessions on it all the time. They have residential, non-residential, breaking out different parts of the building code. They have one coming up on just solar, and like how to model like solar integration into your energy model. So just like break down really nicely all these little details of everything that we're doing right now. So yeah, it's kind of a fun like world. Like once you dive in, you see like it's just a structure that you have to follow basically, and like understanding how to play the rules of it. But if you guys were curious on different ways that you can actually develop a model, this is a really great resource, is going to the documents library after you download the software. And when you download CBEC Res, the free version, they also have a library of all of these examples. Yeah. Yeah, CBEC Res is open source. It's not yeah, we had this whole discussion at the last chat about it, so don't let me go down that rabbit hole again. But basically, like, yeah, CBEC Res, it gives out the same exact report as Energy Pro, but it's a little bit harder to get rolling with it, in my opinion. More steps to do the same work.
But all of the examples you showed are for energy.
Yes, and all the examples. Yeah, so there used to be an option in here where Energy Pro, if you go down to calculations when you're done with your model and you select like Res Title 24 Performance, there used to be an option here where you can output, you would just generate all files when you do your modeling run, and then in your results page you would be able to find like an actual CBEC model. There used to be a function that would allow you to output a CBEC model with your Energy Pro model, but they pulled that functionality out of the software when they updated Energy Pro for some reason. So, not very cool. Yeah, I noticed it when Emily and I were working on a project for, I think it was the Bakersfield house, and all of a sudden it's like, really, I have to redo this multifamily model because I can't just export it in the CBEC. This is so you guys can do the research work on the heat pump water heaters. I was like, oh, so it's still on my to-do list actually. I have to redo it, but hopefully you guys will get suited up so I can have some help. But that would be ideal. All right, everyone joining on Zoom, thank you very much for attending. And
Thanks, Jenna.
yeah, thank you. I'll see you all next time for workshop 3.
Bye.
All right. Bye, Emily. The week after next?